Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in the SOC Level 1 Learning Path, Network Security and Traffic Analysis module. This is the Wireshark Packet Operations Room. Learn the fundamentals of packet analysis with Wireshark and how to find the needle in the haystack. We're going to be covering various different items here. All right, starting from the statistics slash summary, and then protocol details, principles, protocol filters, advanced filtering, and then we're going to wrap it up and go over a summary of what we covered and learned with this room. As usual, if you don't have access to this room, if you're not a subscriber to this room, then you can just follow along with the video and then just take notes. All right, without further ado, let's go ahead and dive into it. Task 1 Introduction. This room, we're going to cover the fundamentals of packet analysis with Wireshark and investigate the event of interest at the packet level. It says take note that this is the second of the Wireshark room trio, and it's suggested that you complete the first room, which is called Wireshark the Basics, or you can check out my channel to see if I have a video of that. I'm pretty sure I do. And it says to practice and refresh your Wireshark skills before starting this one. In the first room, we cover the basics of Wireshark by focusing on how it operates and how to use it to investigate packet captures, traffic captures. In this room, we will cover advanced features of Wireshark by focusing on packet level details with Wireshark statistics, filters, operations, and functions. Okay, so there's a task VM. Go ahead and start that up, which I've already done, and I have to open up in another tab to make it bigger. So we're done with that. First task that we're going to actually take a look at things is going to be this statistics summary. So let's see what statistics is. This menu provides multiple statistics options ready to investigate to help users see the big picture in terms of scope of the traffic, available protocols, endpoints, and conversations, and some protocol-specific details like DHCP, etc., etc. For security analysts, it is crucial to know how to utilize this statistical information. This section provides a quick summary of the process to PCAP, which will help analysts create a hypothesis for investigation. You can use the statistics menu to view all available options. Now start the given VM, open the Wireshark and exercise.pcapng file and go through the walkthrough. Okay, let's go ahead and flip over there. Here it is open right now. Now I'm going to go to file and then open, and then we're going to open up that PCAP file, which is this here. Okay, there we go. There's quite a lot of packets in here, so while that's loading up, let's go ahead and continue on here. Okay, so we're going to look at this statistics as soon as it uploads or loads the file in, and okay, it's done. So statistics right here, and here's the sub menu of it. They're going to take a look at things inside of here. So let's see what they're saying. Resolved addresses. This option helps analysts identify IP addresses and DNS names available in the captured file by providing a list of the resolved addresses and their host names. Note that the host name information is taken from DNS answers in the captured file. Analysts can quickly identify the accessed resources by using this menu. Thus, they can spot accessed resources and evaluate them according to the event of interest. You can use the statistics and then go over to the resolved addresses menu to view all the resolved addresses by Wireshark. So it's going to look something like this. Once you click on statistics and then look at that submenu, you'll see the resolved addresses. Okay, so let's go ahead and do that here. Statistics is open, and then resolved addresses, click that, and here we go. A lot of information here, so let's see if I can make this a little bit bigger. Okay. All right, so we have host information in here. It appears. Then we have ports over here in this tab here. Okay. You can also sort things. So we can sort by port numbers. All right, it's pretty nifty. Comments, nothing in here. So let's flip back over and continue on. Protocol hierarchy. This option breaks down all available protocols from the captured file and helps analysts view the protocols in a tree view based on packet counters and percentages. Thus, analysts can view the overall usage of the ports and services and focus on the events of interest. The golden rule mentioned in the previous room is valid in this section. You can right-click and filter the events of interest. You can use statistics and then protocol hierarchy to view this info. So let's go ahead and do that here. Let's go ahead and close this. Okay, statistics and then protocol hierarchy. Okay, there we go. So a lot of information here to take in. Taking some good notes here. Also, you could probably use this on a different PCAP out there as well. I'll go at the end of the video. I'll show you a place where you can go ahead and take a look at PCAP so you can analyze in like in a lab environment. Okay. So anyway, so there's a lot of information here. You got protocol packets, percentage packets, et cetera, et cetera. A lot of good information here so far. So let's flip back over. Okay. Conversations. This conversations represents traffic between two specific endpoints. This option provides the list of the conversations in the 5 base formats: Ethernet, IPv4, IPv6, TCP, and UDP. Thus, analysts can identify all conversations and contact endpoints for the event of interest. You can use the statistic, then conversation menu to view this information. So let's go ahead and flip back over once again and take a look. Okay, so statistics and then conversations. There we go. It's loading up here. Some more good information inside of here, so you can scroll over and take a look at it. Packets and bits and durations, stuff like that. And it breaks it down here: IPv4 stuff, IPv6, TCP, and UDP. So a lot of good information here. And it looks like you can play around with some things down here as well, flip on and off as needed. Let's see here. Endpoints. The endpoints option is similar to the conversation option. The only difference is that this option provides unique information for a single information field: Ethernet, IPv4, etc., etc. Thus, analysts can identify the unique endpoints in that captured file and use it for the event of interest. You can use the statistics endpoints menu to view this info. Wireshark also supports resolving MAC addresses to human readable format using the manufacturer name assigned by IEEE. Note that this conversation or this conversion is done through the first 3 bytes of the MAC address and only works for the known manufacturers. When you review the Ethernet endpoint, you can activate this option with the name resolution button in the lower left corner of the endpoint. So once we get in there, it'll look something like this here. So let's go ahead and follow along. Close out of this here. Okay, and we need to go to statistics again, endpoints. Okay, well that loads up. So this is what it looks like normally. You have these different tabs up here we take a look at, right? It gives you like country stuff, information like that. So it's some pretty good info inside of this already. Okay, then name resolution, like that. See how it converts everything there? So if you unclick it, it's back to just regular MAC addresses, and then it transforms it into the actual manufacturer name and such for the ones that actually have one for them. So you got Xerox, IBM, Sophos, and so on and so forth. All right, pretty nifty there. Name resolution is not limited only to MAC addresses. Wireshark provides IP and port name resolution options as well. However, these options are not enabled by default. If you want to use these functionalities, you need to activate them through the Edit Preferences Name Resolution menu. Once you enable IP and port name resolution, you can see the resolved IP addresses and ports names in a packet list pane, and also will be able to view resolved names in the conversations and endpoints menus as well. Okay, so if we wanted to do that, we got to go to Edit and then Preferences, Name Resolution. So let's just see what it looks like. Let me close out of this here. Okay, Edit, then Name Resolution. All right, there we go. And then we want to resolve network IP addresses. I think it's the only one I selected. Resolve transport names as well. It's the other one. So let's go ahead and select both of these here. Hit OK. All right, there we go. See, it changed some things here. Now, if we go back to what we were looking at here, I think endpoints I said was one of them we could take a look at, and then IPv4. So let's see, yeah, making sure we're following along here. Yeah, conversations and endpoints. So it'll resolve those names there. If you want to go ahead and flip that switch on. And this is what it looks like here, as we just saw in real time. It transformed into this here. So there's the difference as it looks. Okay, this endpoint menu. All right, pretty neat, but I don't see. Let's see. So there's actually did it, but okay, maybe I am. Okay, there we go. Right there. Now it's doing it. There we go. That's pretty neat. That's pretty neat. Okay, I'm gonna go ahead and close that out. And then it said the other one we could take a look at was the conversations, and we have it down here as well. So here's what it looks like normally, and then if we flip that switch on, there we go. Okay, pretty neat. Let's go ahead and continue on. Besides name resolution, Wireshark also provides an IP geolocation mapping that helps analysts identify the map's source and destination IP addresses, but this feature is not activated by default. It needs supplementary data like GeoIP database. Currently, Wireshark supports MaxMine databases, and the latest versions of the Wireshark come configured MaxMineDB. However, you still need MaxMineDB files and provide the database path to Wireshark by using edit preferences, name resolution, MaxMine database directory menu. Once you download and indicate the path, Wireshark will automatically provide geo information or geo IP information under the IP protocol details of the matched IP addresses. That's pretty neat. So if you get those databases, you'll get some additional information like this. Okay, endpoints of geo IP view, and if we just want to follow along with this, so edit preferences, name resolution. So let's go ahead and get out of this. Okay, name resolution, and then we had to go to what was next? MaxMind database. Right there. So if you go to edit here, then you go and select it. So it looks like some's already in there. All right, cool. Which would explain probably why we were seeing these things transform like that or convert over like that. All right, yes, that's why we were seeing this in there. Okay, that's pretty cool. All right, so you need an active internet connection to view GeoIP map. The lab machine doesn't have an active connection. Okay, I don't think we'll need that anyway. So there's some questions here. Be sure to pause the video, try to answer these questions yourself, connect to the video, and then we will step through it together. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Let's take a look at these questions. Investigate the resolved addresses. What is the IP address of the host name that starts with BBC? So let's go ahead and flip back over here and we're going to go to statistics and resolved addresses. All right. And just going to make this a little bit bigger. All right. So BBC, just go ahead and type it in here. And we see here's the IP address here. So go ahead and plug that in. Next one, what is the number of IPv4 conversations? All right. So we're going to go ahead and check out conversations. Okay. IPv4, and we have 435 there. Next one says, how many bytes, kilobytes, were transferred from the micro ST MAC address? And we're going to take a look at endpoints here. Okay, once you have that sorted out, we're going to need to click this name resolution. Remember, it converts this into the actual name of the manufacturer. And we need to go over to Ethernet. Make sure the right tab here. Okay, so let's go ahead and find that in here. And right there is what we need. And we have 700 or 7,474. Okay, so we're done with that one. What is the number of IP addresses linked with Kansas City? All right, so once again, let's go ahead and take a look inside of here, IPv4, and then we're going to scroll over to the city, and then we're going to sort this, and then for Kansas City. All right, Kansas City, so we have 1, 2, 3, and 4 for our answer there. Next one says, which IP address is linked to the BlickNet AS organization? So we're going to go ahead and scroll over to the AS organization, and once again, we're going to sort it and then find that organization. So it's sorted, so now we need to find it. So it should be in the B's. There we go. Now we're going to scroll back over to the IP addresses, and then we're going to uncheck this name resolution, and then here's the IP right there. It's the one we need. plug in there. So we're done with that task. Task number 3, we're going to look at statistics and protocol details, IPv4 and IPv6. Up to here, almost all options provided information that contain both versions of the IP addresses. The statistics menu has 2 options for narrowing the statistics on packets containing a specific IP version. Thus, analysts can identify and list all events linked to specific IP versions in a single window and use it for the events of interest. You can use the statistics IPv6 statistics menu to view this. So let's go ahead and hop over there and do that. Close out of this statistics, but then let's go ahead and find that. Okay, so we have IPv6 and IPv4 down here. All right, so that's good to know. Okay, and it looks like they went to IPv4 and then all addresses, and they looked at various different options inside of here. So if we just wanted to play around with it, let's just try to follow along. So we'll click all addresses first to get some information in here. Various different tabs you can take a look at. Okay, so that's pretty neat. Close this out. I'm going to go back to it. And then we're going to do the same for destination and ports. Okay, that's pretty cool there. All right, nice. Let's see. DNS. This option breaks down all DNS packets from the captured file and helps analysts view the findings in a tree view based on packets, counters, and percentages of the DNS protocol. Thus, analysts can view the DNS service overall usage, including R code, opcode, etc., and use it for the event of interest. You can use the statistics, then DNS menu to view this information. All right, so this is pretty much, a lot of it is just straightforward, right? Just go to statistics and then go to whatever you're looking for inside of your conversations, endpoints, etc. So we're going to click on DNS. As we scroll through here, we can see what they're talking about: R code, OP codes or opcodes, query response, all that good stuff inside of here. Okay, that's pretty interesting there. And HTTP, this option breaks down all HTTP packets from the captured file and helps analysts view the findings in a tree view based on HTTP protocol. So pretty much a similar thing. All right, so same thing for DNS, we're going to do the same thing for HTTP. So statistics and then HTTP to view this information here. So let's go ahead and follow along. Okay, and let's click on packet counter. See this information inside there. Awesome. And we're going to take a look at another one. Cool. Now, obviously, you're going to need to spend some time to go through all this stuff here and make sure you familiarize yourself with this particular application and these menus and options and such. Okay, so they already have everything here in these screenshots, as we saw as well in the lab environment. And we have question time as well, so be sure to pause the video, go through these questions yourself, and try to answer them and come back to the video. All right, let's take a look at these questions. What is the most used IPv4 destination address? Let's flip back over to the VM, statistics, IPv4 statistics down here, and then destination and ports is what we need. Now this does take about a minute or two to load up all the way. As you can see, it's loading very, very slowly. All right, now while that's loading up, the other website I was talking about was this malware traffic analysis that you can take a look at. They have various different PCAPs in here that you can play around with in a lab environment. So just be careful as you're going through these. Okay, they even give you some information on how to go through these exercises, I believe. So let's go ahead and flip back over to our VM. Okay, it's almost done. So once it's done, we're going to click count up here. And then you can see that this is going to be it here. This 10.100.1.33 should be what we are looking for. Next one says, what's the max service response or request response time of the DNS packet? So we're going to go to and look at the DNS section of statistics. All right, so we're going to flip over to statistics and then DNS. Okay, so once it's fully loaded, I'm not sure if this is needed, but I went ahead and just sorted this, and then service stats, and then the response or request response is going to be this here. So the max value is going to be this 0.46, et cetera, et cetera, et cetera. So that's going to be our answer for that one. And what is the number of HTTP requests accomplished by rad.msn.com? Flip over to the VM. Now we're going to go to statistics and then HTTP, then requests, and I'll bring up this other little box here. Okay, make it a little bit bigger. All right, now we're gonna have to scroll over a little bit to find that. I'm just gonna drag it over. Okay, try to compress things for a little bit here. Okay, so now we need to go and find rad inside of here. Okay, there we go, rad.msn.com. And we see count here is going to be 39, and that's what we are looking for. So go ahead and plug that in, and we are done with that. All right, so we're done with that. Task number 4, look at principles, packet filtering. In the previous room, Wireshark the basics, we covered packet filtering and how to filter packets without using queries. In this room, we will use queries to filter packets. As mentioned earlier, there are 2 types of filters in Wireshark. While both use similar syntax, they are used for different purposes. Let's remember the difference between these 2 categories. So we have captured filters and display filters, or filters. Captured filters, this type of filter is used to save only a specific part of the traffic. A display filter, this type of filter is used to investigate packets by reducing the number of visible packets and is not changeable during the capture. Note, you cannot use the display filter expressions for capturing traffic and vice versa. Okay, so you can just use one or the other according to this, from my understanding. The typical use case is capturing everything and filtering the packets according to the event of interest. Yes, that's typically what I do. If you're going to do a live capture, capture it first, save it as a PCAP file, and then start analyzing it afterwards with the filters. Only experienced professionals are use captured filters and sniff traffic. This is why Wireshark supports more protocol types and display filters. Please ensure you thoroughly learn how to use captured filters before using them in a live environment. Remember, you cannot capture the event of interest if your capture filter is not matching the specific traffic pattern you're looking for. All right, capture filter syntax. These filters use byte offsets, hex values, and masks with Boolean operators, and is not easy to understand / predict the filter's purpose at first glance. The base syntax is explained below. So you have scope, hostnet, port, and portage, direction, source, destination, protocol, ETH, WLAN, etc. Sample filter to capture port 80 traffic. So this is something that you could use. They're showing you what it looks like if you were to use this. So TCP and then port 80 is where you're going to be filtering for. You can read more on capture filter syntax here and here. So check those out to familiarize yourself with that. A quick reference available under capture and then capture filters menu. So if we want to flip back over there, and it was under capture and then capture filters right here. Okay, that's pretty neat. Okay, display filter syntax. This is Wireshark's most powerful feature. It supports 3,000 protocols and allows conducting packet level searches under the protocol breakdown. The official display filter reference provides all supported protocols breakdown for filtering. Sample filter to capture port 80, TCP.port equals to 80. Pretty neat. Wireshark has a built-in option, display filter expression, that stores all supported protocol structures to help analysts create display filters. We will cover the display filter expression menu later. Now let's understand the fundamentals of the display filter operations. A quick reference is available under Analyze and then Display Filters. So if we want to take a look at that, close out of this. Okay, Analyze and then Display Filters. Pretty neat. It has these in there for you, right? You can also plug them in here. It says apply a display filter. So there you go with that. Comparison operators. You can create display filters by using different comparison operators to find the event of interest. The primary operators are shown in the table below. So English, C-like, description, and example. So EQ equals to C-like, and then description equals. And then here's an example, and then you can see the rest here, not equals, greater than, less than, etc., etc. So pretty neat, something to take note of here. Notes, Wireshark supports decimal and hexadecimal values in filtering. You can use any format you want according to the search you will conduct. Logical expressions. Wireshark supports Boolean syntax. You can create display filters by using logical operators as well. So once again, you have and, or, and not, and this is how you can do them inside of Wireshark here. So it's a lot of things you can do inside these particular filters and such. Packet filter toolbar. The filter toolbar is where you create and apply your display filters. It is a smart toolbar that helps you create valid display filters with ease. Before starting to filter packets, here are a few tips. Packet filters are defined in lowercase, so remember that. Packet filters have an autocomplete feature to break down protocol details, and each detail is represented by a dot. Packet filters have a three-color representation explained below. Right, so green, valid filter. So green, good, red, bad, and valid filtered, and yellow, warning filter. Filter works, but it's unreliable, and it's suggested to change it with a valid filter. And this is an example of what they look like here. So green means go or good, red means bad. Change your syntax, check your syntax, and then yellow is a warning filter. All right, pretty straightforward so far. Filter toolbar features are shown below here. All right, so it's just giving an example of other options of this like autocomplete, right? So if we want to try that out, let's just do IP, and it gives you a breakdown here. So this has come up quite a bit from back in the day. I don't think it even had this autocomplete or anything like that. So this is pretty fancy stuff here. Pretty cool. We covered lots of principles and syntax. Let's put these into practice and start filtering the next task. Awesome. So task number 5, looks like we're gonna get into practical app. Protocol filters. As mentioned in the previous task, Wireshark supports 3,000 protocols and allows packet level investigation by filtering the protocol fields. This task shows the creation and usage of filters against different protocol fields. IP filters. Help analysts filter the IP traffic according to the IP level information from the packets. This is one of the most commonly used filters in Wireshark. These filters filter network level information like IP addresses, version, etc., etc., etc. The common filters are shown in a given table here. So you have filter and then description IP, show all IP packets, IP.address equal to or equals the IP address here. And then you can see the rest as well. So you can do subnets and then source IP, destination IP. So a lot of neat stuff here. Make sure you're taking notes. IP.address or ADDR versus IP.source/IP.destination or DST. Okay, and explains it here. All right, so that's good to go. Pretty interesting stuff here so far. So you can do a lot of stuff with Wireshark. It's very, very versatile and robust. So TCP and UDP filters. TCP filters help analysts filter the traffic according to protocol level. Okay, these filters filter transport protocol level information like source, destination port, sequence number, etc., etc. So you can filter on TCP, and then another one you can filter on UDP ports. It's just pretty much straightforward, self-explanatory. You can see here more information in these tables if you want to try these particular filters out yourself. All right, so I'm just going to go ahead and just grab this one, I guess, and plug it in here just as an example. All right, hit enter, and it's loading. Now I just filtered on port 80, right? And it's going to show me all that information. And I'm going to clear it out here by clicking this X. Okay, now I'm back to what it was before. All right, so pretty much straightforward here. Application level protocol filters, HTTP and DNS. So basically the same thing here. You're filtering on these protocols instead of particular ports or IP addresses, okay? You can see the table here that gives you some inkling of what they look like, right? So you can just take these as your notes because you're probably going to use them later on or sometime in your IT career. You'll come across Wireshark and needing to analyze PCAP. So this is very useful information here. Display filter expressions. As mentioned earlier, Wireshark has a built-in option that stores all the supported protocols, which we saw earlier. When an analyst can't recall the required filter for a specific protocol or is unsure, the display filter expressions menu provides an easy-to-use filter display, builder guide, so analyze display filter. All right, so let's just go ahead and look at it again real quick. Analyze display filters. Okay, let's just select TCP. Actually, let's just go to HTTP only since we just did something similar. Okay, and I believe that's it, right? Does it? Okay, so it's supposed to, let's go ahead and read on here. It's impossible to memorize all the filters. Okay, display filter expression menu shows all protocol fields, accepted values. Note that it will take time and require practice to master creating filters and learning the protocol. So if you want to use this, go to the display filter expression and select whatever you want to use, and then select the other criteria accordingly. Right, so it's basically like a wizard of building out these filters, right? And then it breaks it down. Here you click OK, and then it'll show up in that display bar, right? So let's do this again. Expression is the one we need to click on. Okay. Now we have various different ones we can choose from. So, wow, there's a ton in there. So let's just try HTTP. Okay, there we go. There's a lot in there. We'll just select this one. Okay, and we'll just leave it like it is present. Okay, and then click OK. Now we have it up there. And you can hit enter or hit this here to run it. And now we're filtering on HTTP traffic. So that's pretty cool that's in there. Note, the first room introduced the coloring rules. Now you know how to create display filters and filter the events of interest. You can use the view coloring rules menu to assign colors to highlight your display filter results. Awesome. So once again, pause the video and then answer the question yourself, then come back to the video and we will continue on. What is the number of IP packets? Now, remember, we can filter on that specific information using that display filter. So let's go ahead and do that. I have IP already plugged in there. So I'm just going to hit this arrow here, hit enter on it, and then you should see down here where it says displayed. That should give us our answer. As soon as it loads, it wants to lag a little bit. So 81,420 is going to be our answer there. Next one says, what is the number of packets with a TTL value less than 10? Once again, you can use the filtering options, and if you need help with this, remember we can go always to this analyze and then display filter expressions. Help us build out that specific information. So if we want to go in and type it in, TTL. So um, if it's not in here, it's just going really slow. But anyway, all right, since this is going to lag, anyway, you can use this display expression to build out your queries, and I already have it here. So I have IP.ttl, and then less than 10 is going to be what we're looking for here. So I'm just going to copy and paste this over. And once again, it has this auto filter as well. So if you want to just build it out this way, you could do that. Okay, so this is an example IP.ttl, right? Then less than 10. Enter. Okay, once it's finished running, it should be down here at 66, should be our answer for displayed. Next one is what is the number of packets which uses TCP port 4444? So once again, use those filters that we learned about earlier up here, right? You can filter on those ports and everything. So that's exactly what you're going to do here. So I'm going to go ahead and just grab it out of here. So I already have it ready. So TCP dot port is going to be equal to or equals 4444. Okay. So I'm going to delete all this out and just paste it in. This is going really slow today. It's very annoying. Hit enter. So once it's done, you're going to get the answer down here, displayed 632. So that's our answer there. And next one is what is the number of HTTP GET requests sent to port 80? So once again, use those filtering, use that builder to filter it out, or you can just use autocomplete. Right, so anyway, this is what you should get, or something similar to this, http.request.method, right? Because we're looking for the method, and the method is going to be get, right? Make sure you have these double quotes in there for the string, and then you're going to combine it with the and then the tcp.dest port, because that's the destination port, because it's asking for a request sent to port 80, and then it's going to be equal to 80. So there we go there. I'm just going to copy and paste it over. Enter. Okay, so once it's done, you can see there at the bottom, it displayed 527 should be what we're looking for. And the last one is what is the number of type A DNS queries? Now, once again, you're going to need to combine these, right? So first off, you're going to look for the DNS queries. If we scroll up a little bit, you can see what they're talking about here, right? So show all DNS A records, and then show all DNS requests, DNS responses. And if you take a look at my example here, all right, so we're looking for A, and then we're combining it with this flag.response equals to 1, because you're going to be looking for those. You need to find the responses is what we're looking for in these, or you need to filter those out is what I should say. Okay, so paste this in. Once it's finished running, we should get our answer here shortly. 51 is what we're looking for here. So there we go. Task number 6, advanced filtering. So far, you have learned the basics of packet filter operations. Now it's time to focus on specific packet details for the event of interest. Besides the operators and expressions covered in the previous room, Wireshark has advanced operators and functions. These advanced filtering options help the analyst conduct an in-depth analysis of an event of interest. So once again, here's some filters, contains, all right, and explains what it is here. Comparison operator, description, search of value inside packets. It is a case sensitive and provides similar functionality to the find option by focusing on a specific field. Example, find all Apache servers. Workflow, list all HTTP packets where packets server field contains Apache keyword. Usage, HTTP.server contains Apache. And this is an example of what they're talking about here. So this is very useful. And then you have matches, which explains what this is as well. Comparison operator, search a pattern of regular expression, case insensitive. Example, find all .php and .html pages. List all HTTP packets where packets host fields match .php or .html. And here's an example of the usage here, HTTP.host matches. Then inside these double quotes here, you have the backslash dot, and then inside open and close parentheses, PHP, pipe, HTML. All right, in this example, what it looks like here, you have the filter in membership, search a value, or field inside of a specific scope or range, find all packets, et cetera. And here's an example of what that looks like here. So you're looking for a specific range or scope in this. So they're looking for ports in 80.443 and 80.80, right? And that should hold back that particular information. Next one is upper. So it says that convert a string value into uppercase. Find all Apache servers, and Apache is in all caps. Here's an example of that looks like upper, and then HTTP.server contains Apache. Okay. Lower, same thing, just opposite. All right. String. Convert a non-string value to a string. Find all frames with odd numbers. Convert all frame number field string values and list them. List frames and with odd values. Okay, so string looks pretty useful here. Bookmarks and filtering buttons. We've covered different types of filtering options, operators, and functions. It is time to create filters and save them as bookmarks and buttons for later usage. As mentioned in the previous task, the filter toolbar has a filter bookmark section to save user-created filters, which helps analysts reuse favorite/complex filters with a couple of clicks. Similar to bookmarks, you can create filter buttons ready to apply with a single click. Some really fancy and interesting things. I don't think I've ever done this level of filtering inside of Wireshark. I usually keep it to the basic level at the most part, and maybe a little bit um, further than that. But I've never gotten into like bookmarks and filtering buttons and stuff like that. I'm not in Wireshark on a daily basis or anything like that, but this is very interesting stuff here, and this just walks you through the steps of creating bookmarks, right? So basically, just saving these particular queries, filters, what have you. So it says add display filter button, click that plus sign, and then inside of here, select the criteria, and then it says odd frames, it says find all frames, yada yada yada. So I guess that's the description you can plug in there. So let's see here. Does it even let me do it? Let's see. Okay, we'll go back to that later if we need to use this. But let's go ahead and continue on. Profiles. Wireshark is a multifunctional tool that helps analysts to accomplish in-depth packet analysis. As we covered during the room, multiple preferences need to be configured to analyze a specific event of interest. It is cumbersome to rechange the configuration for each investigation case, which requires a different set of coding rules and filtering options or filtering buttons. This is where Wireshark profiles come into play. You can create multiple profiles for different investigation cases and use them accordingly. You can use the Edit Configuration Profiles menu or the lower right bottom of the status bar profile section to create, modify, and change the profile configuration. So if you want to do that, you can do it like so. So let's just follow along here. And it says the first option, Edit, and then Configuration Profiles. So Edit Configuration Profiles or Control-Shift-A for short, and there you go here. that's pretty neat. Saves you a lot of time, right? If you're going to be using Wireshark on a daily basis. Okay, once again, question time. Pause the video, go through these questions, answer them, come back to the video, and then we will go through it together. Let's take a look at these questions here. Now, there are hints here, and I use several of these hints because, like I said, I'm not an expert in Wireshark, and I'm not in Wireshark all the time or using these fancy buttons or advanced areas here inside of Wireshark. But anyway, let's get to it. Find all Microsoft IIS servers. What is the number of packets that did not originate from port 80? So let's flip back over here, and I'm going to check my notes. Now we're going to look for http.server contains IIS and does not equal source port 80 is what this one is saying here. So I'm going to copy this, paste it over, enter, then down for displayed, should get our answer 21. Next one, find all IIS servers. What is the number of packets that have version 7.5? So this one's similar to what we just did, except for we're changing the last part of it to http.server matches 7.5 instead of double quotes. Okay, so clear all this out. Then it says displayed 71 for our answer there. And then it says, what is the number or the total number of packets that use ports 333 and 44449999? Okay, now we can use that range or scope, whatever they're talking about earlier, right? So that's exactly what I did here, tcp.port in this range or scope. So I'm going to plug that one in to get this answer here. Hit enter. Once it's finished running, it should be our answer there, 2235 for that one. And the next one, we're going to look for what is the number of packets with even TTL numbers. Now, like I said, this one's a bit tricky for me, but this is the way I did it here. So string IP.ttl, then matches 24680, and then $ at the end there. So you can check the hint as well to give you some things to use here. So they're using this regex value. Okay, so I'm going to plug this in. Okay, so once that's finished running, we should get our answer there for the number of packets. Okay, so 77289 for displayed. The next one is we're gonna look for checksum. We're gonna switch over to the checksum control profile, and then what is the number of bad TCP checksum packets? Now this one, you'll have to use that expression. At least I did. So I already flipped over. So from default, I want to flip back. Here's the default. Flip back over to the checksum control. It's finished. You can go to the, I believe it's under Analyze, and then Display Filter Expression, and then you can search on it here. This one can take a bit to look for, so I'm gonna look for TCP. I think it was .checksum. So let's see, checksum. There we go. So TCP is what we need here, and then for this one, we need the status. So tcp.checksum.status, what we're looking for here, and then bad. So this is already set for us, and then this is what's going to plug it into the filter. Hit OK, and I need to get rid of this stuff first. So delete all that. Now enter. So once it's finished running, we should get our results back. Okay, and that should be our answer, 34,185 for the displayed. Okay, and then the last one here says, use the existing filtering button to filter the traffic. What is the number of display packets? Now this one's easy. You just go over here to this button where it says GIF/JPEG with HTTP 200. Click that, and first, let's clear all this stuff out. And then we'll click that button. Enter. Okay, so there's our answer there. Displays 261. So we're done with that. And we're going to close out to conclusion. I just finished the packet operations room. We covered statistics, filters, operators, and functions. Want to learn more? invite you to complete the Wireshark traffic analysis room to improve your Wireshark skills by investigating suspicious traffic activities. That's probably going to be our next video, actually. But um, like I said at the beginning of the video, there is this malware traffic analysis website here, and I'll have the link in the description if you want to do some more lab work or hands-on keyboard experience dealing with actual PCAP files that were found out in the wild. I recommend taking a look at that to familiarize yourself better with Wireshark. So let's go ahead and close this out. Conclusion complete. Now, if you enjoyed this video, you want to support the channel, be sure to hit that like button, comment, subscribe with that notification bell so you know every time I upload a new video to the channel. As always, thank you all for your continued support. Have a nice day, and I will see you later.